There are 200 billion stars in the Milky Way. Scientists estimate that roughly 40 billion of them have Earth-sized planets sitting in what astronomers call the habitable zone, the band of distance from a star where liquid water can exist on a surface. 40 billion chances. 40 billion shots at life. And the Milky Way is one galaxy. There are 2 trillion galaxies in the observable universe. The numbers are incomprehensible. So let's make them simple. Even if only 1 in a million of those 40 billion habitable planets produced intelligent life, that would still be 40,000 civilizations in our galaxy alone. And some of those civilizations would have had a billion-year head start on us. A billion years is enough time for a civilization to colonize every star in the Milky Way several times over. So where are they? We have been scanning the sky for signals from space since 1960, 64 years of listening. Billions of stars surveyed. The most sensitive instruments humans have ever built pointed at the galaxy and left running. The Breakthrough Listen project, $100 million, 10 years, a million stars. We have found nothing. Not one confirmed signal, not one probe, not one megastructure, not one artifact. Just silence across 2 trillion galaxies and 400 years of searching. This is the Fermi Paradox. And it is the strangest fact in the history of science. In the summer of 1950, the physicist Enrico Fermi was eating lunch at Los Alamos National Laboratory in New Mexico with a group of colleagues. They had been talking about extraterrestrial life casually, the way scientists sometimes do at lunch, and the conversation had moved on to something else entirely. Then Fermi went quiet. He sat for a moment, and then, completely out of nowhere, he looked up and asked a question that no one at the table could answer. Where is everybody? It sounds like a simple question. It isn't. Fermi had calculated something in his head that has troubled physicists ever since. If you take the age of the universe, the abundance of stars, the number of habitable planets, and even conservative estimates for how often life arises, the math produces a galaxy that should be full of civilizations. And here's the detail that matters. Once a civilization develops self-replicating machines probes that can travel to a new star system, use local resources to build copies of themselves, and send those copies onward, they can fill the entire Milky Way in approximately 4 million years. 4 million years sounds like a long. The dinosaurs ruled the Earth for 165 million. 4 million years is a rounding error in cosmic, which means any civilization that got even a modest head start on us should have reached every star in this galaxy before multicellular life exists. Earth, they should be here right now. Their machines should be everywhere, every planet, every asteroid belt. They're not, and nobody knows why. In 1961, the astronomer Frank Drake tried to make the question more precise. He built an equation, the Drake equation, that multiplied together every factor that determines how many communicating civilizations the galaxy should contain: star formation rate, the fraction of stars with planets, the fraction of planets where life emerged, the fraction where intelligence evolved, the fraction that developed detectable technology, and how long those civilizations survived. The equation has one problem. Nobody knows what numbers to use. Optimistic values and you get thousands of civilizations. Use pessimistic values and you get one, just us. And both answers are deeply strange because if the galaxy is full of civilizations, why haven't we found them? And if we are truly alone in 2 trillion galaxies, why us? This unremarkable planet orbiting this perfectly average star in the outer arm of one ordinary spiral galaxy out of trillion? Both possibilities, when you sit with them long enough, feel impossible. But here is where it gets genuinely unsettling. In 1998, the economist Robin Hanson at George Mason University proposed what he called the Great Filter. The idea is this: somewhere along the path from simple chemistry to interstellar civilization, there is a step so unlikely that almost nothing gets through it. A filter. Something that stops civilizations from reaching the stars. The question, the one that keeps physicists up at night, is whether the filter is behind us or ahead of us. If the filter is behind us, we are the lucky. Maybe the hard step was the origin of life itself, the leap from dead chemistry to a self-replicating cell. Maybe that leap is so improbable that it almost never happens anywhere in the universe. If so, we made it through. We are the exception. The silence makes sense, but if the filter is ahead of us, if life arises commonly, if intelligence arises commonly, if thousands of civilizations have reached roughly our level of development, then something is destroying all of them before they reach stars. A technology they built and couldn't control. a threshold they crossed and couldn't survive, something that ends every civilization at a predictable stage of development. If that is true, the silence is not emptiness. It is a graveyard. And Hansen made one more observation that is worth sitting with. He said that the worst possible news we could ever receive, worse than an asteroid on a collision course, worse than any geopolitical threat, would be the discovery of independent life anywhere else in the solar system. On Mars, on Europa, on Enceladus. Because if life arose independently twice, just within our own solar system, it means life arising is not the filter. The filter is something later, something we haven't faced yet, something ahead. Carl Sagan spent his career hoping we would find life elsewhere. Robin Hansen says if we do, we should be terrified. On August 15th, 1977, a researcher named Jerry Amon was reviewing radio telescope data at Ohio State University when he found something that matched every characteristic of an interstellar transmission. A signal on the hydrogen line, the frequency that physicists had long predicted an alien civilization might use to make contact coming from a specific point in the constellation Sagittarius. Amon circled it on the printout. In the margin, he wrote one word. Wow. The signal lasted 72 seconds. It was never detected again. No natural source has ever been found that explains it. It remains, to this day, the strongest candidate for extraterrestrial contact in the history of SETI. We don't know what sent it. We don't know if it was a natural phenomenon we don't yet understand, or something deliberate, or something in between. We don't know if somewhere out there, something was trying to reach us once and we weren't paying attention, and it gave up and moved on. The universe has been around for 13.8 billion years. We have been listening for 64. Maybe the silence means we are alone. Maybe it means we are early. Maybe it means everyone who came before us hit the filter. Maybe it means something is out there that has learned to stay quiet for reasons we don't yet understand. Fermi asked his question at lunch in 1950, and nobody could answer it. 75 years later, with better telescopes, more powerful instruments, and more data than Fermi could have imagined, the answer is the same. We don't know where everybody is, we don't know if anybody is out there, and the more carefully you look at the numbers, the more the silence starts to feel less like emptiness and more like a message we haven't learned to read yet.